Welcome to Brain Vision.
Let's use the chain rule to find these partial derivatives. So here, let's see what's going on here. We see that z is a function of two variables, x and y. And then we see individually that x and y both depend on s and t. So we'll need some partial derivatives here. So our formula, dz over ds, that's the first one that they want. So this is using the chain rule here. This will be the partial derivative of z with respect to x, and then the partial derivative of x with respect to s. And then similarly for the derivative with respect to y, and add these together. It's a ds at the end. Okay, so then now let's go ahead and compute some partial derivatives. So derivative of z with respect to x, we'll use the product rule there. So the first derivative, that's 1 over 2 radical x exy. And then for the next term, let's go ahead and differentiate that exponential and then use the chain rule there. That'll bring down the y. And then let's find dx over ds. So derivative of x with respect to s, that's just t. Then the next one, we see derivative of z with respect to y. So here you just have to differentiate this part because that has the y. Use the chain rule again, bring down the x. And then if you'd like, you could go ahead and combine those x's. And then we have another partial derivative of y with respect to s. And that's just 2s. So let's go ahead and plug all this in. So our first term, that was 1 over 2 radical x exy plus radical x y exy multiplied by derivative of x with respect to s, that was t. And then the derivative of z with respect to y, that was our x to the 3/2, and then exy. And then multiply that with derivative of y with respect to s, that was 2s. So this is one of our answers. Derivative of z with respect to s. And then now we'll have a similar formula, but this time for derivative of z with respect to t. But luckily, we'll see in a moment that we can recycle these formulas and use them again. So this time, just replace all the s's with the t from this equation over here. So those might look like 2, sorry about that, but these are supposed to be this is my notation for the partial derivative. So here we'll just have to go to the side and compute these two partial derivatives. We haven't done these yet, but these are not too bad. Derivative of x with respect to s, that's just t. Oh, excuse me, this time we're doing, sorry about that, derivative with respect to t, and this time it'll be s. And the derivative of y with respect to t, power rule over here, that's negative 2t. So now we're almost done here. So the last thing is to just plug this all in. dz over dx. We did that already, that's up here. And then, so that this is in the top, then add the radical x there. Kind of running out of room here, I'm trying to be careful. So that's a e down there, let me fix that. So that's derivative of z with respect to x. Then we'll multiply by this, which was s. Derivative of z with respect to y, that's up here. And then finally, derivative of y with respect to t, that was minus 2t. So that gives us our other formula, which was the derivative of z with respect to t. So these two formulas, the one circled in red, over here circled in black, those are our final answers.